if I can be a bit more consistent here. So the first thing, let me go back here and let me open up the assignment. So I'm going to go to modules, and we are looking at, does gravity exist here? And if it's something that you don't, you can just, if you don't want to listen, you can cut it off. But using the data in the Does Gravity Exist lecture, I want you to calculate a gravity value and find the percent error, a gravity value. Ugh. And find a percent error using Microsoft Excel. You will have to build your own your own workbook from scratch. So this resource was uploaded last term, and I should have put in on ground because we just did it in the actual classroom. And so it's all kind of like out of place. But let's go ahead and do that real quick. So I am going to go to Teams here and just do this properly. Let's see. All right. So this was the idea. We have ourselves the planet, Earth. Okay. And Earth has a mass, E, and it also has a radius. All right. So we have some R sub E here. And we also have the universal gravitational constant. So each one of those things we'll need to find. And let's just go ahead and find the first thing here. And so I'm just going to find the mass, the Earth. So right here, we have ourselves a little picture here is what, 5.97. I copy that. Copy. And I'll just go back here. See if I can paste that. All right, so I'm able to paste it. So let's see. Don't really like that pasting. Just going to get rid of that. So that was 5.9. Memory is absolutely spectacular. 5.972 times 10 to the 24th kilograms. That's huge. And then we have our radius here. So let's look at the radius of the Earth. And I would like it in meters. So that is 6.371 times 10 to the 6th meters. All right. Then the universal gravitational constant. Universal gravitational constant, there it is popping up. It's going to be 6.6743 times 10 to the negative 11th meters cubed over a kilogram over seconds squared. That's what the -1 and the -2 means. So according to the universal law of gravitation, okay, that is force of one mass on another mass is equal to the universal gravitational constant times m times m2 over the distance of separation between the two. In our particular case, we're going to have ourselves a little mass very close to the surface of the Earth, and we're going to call that m1. That's going to be 1 kilogram. Okay. And so we're going to let m2 equal to m(e), which is the mass of the Earth, and we're going to let the radius equal to the radius of the Earth. We're going to neglect the radius of the particle because it's so much smaller. So we'll end up with, let's just call this f(g) equals to this capital G times one kilogram. So again, our m(1) is equal to 1 kilogram times the mass of the Earth over the radius of the Earth squared. So what we'll look at is f(g) over 1 kilogram. So g m(e) over r(e) squared. This is what we're calling gravity. And I would rather refer to it as the gravitational field. Okay. So all we need to know is the universal gravitational constant, all in m(e), r(e), and so we're going to end up putting this formula into Microsoft Excel. And this is going to be our theoretical, what I was calling theoretical value. It wasn't even the accepted value. 9.81 is the accepted value, but in this case, we're actually doing a calculation based on the mass of the Earth and the radius of the Earth. And so let's go ahead and do that. I'm just going to go ahead and stop sharing my screen here. And I want to open up a Microsoft Excel document. Okay. If you did this according to how I did the video before, that's fine. That's totally fine. But let me share this screen. All right, here we go. Let's see that I'm sharing it. All right. And let me make this a little bit bigger. All right. So what did we need? We needed the universal gravitational constant, and we said that that was in meters cubed divided by kilograms times a second squared. Close that parenthesis. Those are the units. I'm going to wrap that text. All right. And then we needed the mass of the Earth. This is just going to be in kilograms. This is one of our standard units. And then we have the radius of the Earth. And this, of course, is going to be in meters. That's our standard unit as well. Kilograms, meters, and seconds. We call it the MKS system. That's our international system. So now we can do our calculation. The gravitational pull all right, gravitational pull near its, so this is going to be in meters per second squared. Right? So now we're just going to do that calculation. Yeah, universal gravitational constant. It's going to be 6.6743 E negative 11. And then we have the mass of the Earth is going to be 5.972 E 24. And then the radius of the Earth is 6.371 E 6. All right. And I think I have 1, 2, 3, 4, 1, 2, 3. So So this one was only 3 significant figures, and this one was only 3 significant figures. Well, 4 significant figures, 4 significant figures, and then we had 5. We had 5 significant figures for the universal gravitational constant. And so because of that, we can only take 4 significant figures since those are that's the smallest one that we have. So when we come out with our calculation, which is just going to be G, and that's this value, times the mass of the Earth divided by the power of the radius of the Earth. That's going to be to the second power. So let me go ahead and just copy this formula. So as I continue to write, you guys will still have access to that formula. Right? And we don't need this in scientific notation. We're going to put this in general notation. And we only need 4 significant figures. You guys can see all of these significant figures here. That's not repeatable by someone in a different country using the same tools. So let's go ahead and remove all of those decimal places. And we're just going to go down to 4. So we have 9.82 for our gravitational pull here. All right. And so.
Okay, I did not get that. I got 9.81 E plus 00. I think I have some formatting somewhere.
So go here to go as opposed to scientific. I want you to go to the format and change it to general. Does it look like this? Bree?
Yeah, but now I got 9. I still don't have the same number as you.
That's okay. That's okay. What do you have? 9 point what?
9.813646787.
So now this is a very good example. Now let's reduce all of those decimal places down to 4 significant figures. And tell me what you have.
I got 9.814.
9.184.
No, 9.814.
Okay. What did you, how many significant digits do you have here?
All right, mine does not look like that. Hold on. 7. Yeah, when I enter in that number, it just drops it to 6.67 E minus 11.
6.67. So you can select on this and then increase your decimal places.
Okay.
You should have 4 decimal places there.
Okay, yep, now it all equals. Okay.
Okay. What is your, so do you have 3 decimal places here?
No, let me change that real quick. But I still have now I have the 9.820 under the gravitational pull.
Okay. But I just want to see if you have these. I just want you to have this many decimal places, and I want you to have this many decimal places.
Okay, yeah, I fixed it.
All right, so you have the same value here. I'm interested to know if you have, I'm going to go back to general here. Does your number, select general for this value, and is your number exactly the same as this?
Yes, it is now.
Okay, okay. So now let's go ahead and go down to, let's reduce this to 4 significant figures, which is the 9, the 8, and the 2, and the 0. The 0 is significant because it comes after. So it says that we can measure down to that point. All right. So now this is the gravitational, and I'm saying gravitational pull. This is our, yeah, I'm going to say our theoretical version. Gravitational pull, because we're going to have, and I'm just going to change this sheet to theory. And then here we have our measurement. But I want to do this measurement. I shouldn't do it again. And so just to make the video complete. So what I'm going to do is I want to go back here and I want to pull down my resource. So you guys have to pull that resource down. I'm just going to say it should be in my downloads. Here it is. So I want to open this. It's already open. Let me open up another one here. Let me just save this. Save as. So let me go ahead and open that again. Let me see. Not that one. Shoot. It's already open. Well, let me go ahead and download this again, since I was saving it. All right, so now I'm just going to copy all of this data here. I'm going to select A, B, and C. In fact, I'm just going to select the whole thing. I'm just going to copy this. And I want to take it over to that other sheet here. So even though I have measurement here, I'm going to go to a different measurement or make a different sheet. And I'm just going to paste all of my data in there. So I'm going to call this measurement 2. It's exactly the same as the measurement 1, but this is going to flow in order here. And so let me go ahead and increase the size of this. So now all we need in this case is what's on the velocity in the y direction, as well as the velocity, as well as the time. So we don't need x, y, and the x velocity. I am just going to hide those columns. We're just going to use these 2 columns, and we want to chart those 2. And I may not be able to chart them properly if I have those still there. So I'm just going to delete those columns. So I'm going to select both A and B. I'm going to go to Insert, and then I am going to go to this particular charting. Goodness, here. All right. So now the first thing we talked about before was adding titles. So I'm going to add the chart titles here. The first chart title is going to be what's happening in the vertical. What's happening in the vertical? The horizontal. What's our measure?
Time.
And that is in minutes, seconds, hours.
Seconds.
Excellent. And then we have our vertical axis here, and that is the velocity in the vertical direction, right? And this is going to be in meters per second, right? And yep, the vertical direction, that'll be fine. And so now I'm just going to change this, and I'm just going to say our time correlation to the velocity in the vertical and I'll leave that like that. So we have all of this. I'm just going to go ahead and I think let's change our axis options, and let's go from 0 to 0.4. And then let's go from 2 to, it looks like 1.8. Okay. Oh, I probably should have done that after this part. So we see that this is going to go to about 1.35. Again, I want to go ahead and go down here to 1.35. And I think, nope, it's right here. What we want to do is we're going to exclude the data after this. Now, what's happening? The ball is falling, 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 and then it bounces. So then it rises, its velocity in the vertical direction becomes positive. So we consider that positive, and then it starts to descend again. Notice the slopes for both of these, for both of the declines. They are identical, which is still letting you know that gravity is having the same impact on these as on this ball as when you drop it or after it bounces and starts to come back down. So we're going to go down to 135. I'm just going to select the chart. I want to go back down to the end of the data here, and I'm going to bring this up. And I want to stop right before the yellow section that I selected. And you'll see now we have ourselves a chart here. And again, we have all of this dead space. Let's fix this real quick. Axis options, and I think we put a 3 here, and this looks like maybe 1.4. It's maybe even a 2. So 2 is, that's allowing us to capture all of the information here. So I'm changing I'm selecting on the number line, then I'm selecting on this axis options, and I'm going to go to axis options. It's allowing me to change my bounds from a minimum of 0.2 or something lower than that or something higher to 1.4. And I believe that this is sufficient in capturing all of the information that we need to capture here. And it probably would be great for us to do the other section, even though it's carrying the same slope. So we have our time here. I'm going to go ahead and add a trend line. So I'm just going to select on the plus sign. I'm going to go down to the trend line option. Then I want to select on this arrow. I'm going to go to more options here. And then you'll see that it's selecting a linear trend line here. Okay. And so I want to display the equation on the chart as well as display the R² value. All right. And so let's see here. It's 9.7499. This is the change this to something like that so you guys can see it. So again, our slope, we're looking at our slope here when it comes to comparing what's taking place. And so we can go back to our theory, all right? And we're going to take this slope and put it in our theory. Before we even do that, let's just go ahead and say our measured value for the gravitational pull, the surface of the Earth. Again, this is meters per second squared. So of course I'm wrap at center and middle of those things. And so here is that value. I'm just going to type that in. This is equal to a negative 9.7499. Okay. So we're just going to take this back over to our theory section. I'm going to say equals to, and I'm selecting on our measured value for the gravitational pull near the surface of the Earth. And since I fill that one, I can just fill down, and it's going to give me this information here. So again, all I did was I typed everything in on this page, and then I'm referring to it on the theory page. And you guys can easily type it in. I'm being probably extra. So we want our percent error between the theoretical and measured So the measured value for the gravitation, I say for gravitation pull, that should be gravitational. For the gravitational pull near the surface of the Earth, and that should correct it right on the theory page. A theoretical gravitational pull of the Earth of the object near its surface. Okay. Make this a little bit readable. All right. So we know that this is just going to be equal to our ABS of, and I need to, this is actually going to be a negative sign here. So this is going to be equal to ABS. Now do both of them. Minus this value divided by our theoretical value. And we are going to make this a percentage. And of course, I want some decimal places here. We could stop at 3. And I also need to make sure that you guys have the formula. Right. I'm hoping that that helped you guys out there. Are we good, folks? Did I leave y'all behind? Do y'all understand what I'm doing? All right. Well, I guess that's it.
I'm trying to hold on. I was trying to get it to the percentage because when I changed to percentage, it just went 1.
Oh, yeah. So with this one, you go to your decimal places. So if I remove all of my decimal places, I get 1. But if I place them in there, you see right up here at the top.
Oh, okay. Yeah, I got it now.
I figure that since our lowest value or our lowest significant figure is 4, I'll just stop it at, actually, that's not 4. It would actually be 1 more decimal place. Because the zeros in front of it, those are not significant, but. All right. Antoine.
And real quick, this is what we turn in, right?
Yes.
Okay.
All right, I'll stop sharing here. Stop the video.